Alright, so this is the demonstration lecture on CNC manufacturing, the CAD phase. Up to this point we have talked about just the initial overview about the five basic steps of or phases of CNC milling, and this is going to be, or CNC manufacturing I should say, this is the CAD phase. So the CAD phase, first of all we have to understand what CAD is. CAD is the acronym for Computer Aided Design. You will also hear sometimes, or used to at least, CAD with two Ds, Computer Aided Design and Drafting. But in general it's Computer Aided Design. CAD was developed in the 1960s because of the need for more accuracy. See, at that point computers had started to come into more and more businesses, and people that were familiar with computers said, you know what, a lot of these paper drawings, which were of course being used at that time, were not as accurate as they needed to be. So parts were being made incorrectly. So obviously the computer led to the development of CAD. It's kind of which came first, the chicken or the egg? Well, the chicken being the computer came first on this one. So, and then CAD, Computer Aided Design, came after that. Here's an example of CAD, and what we're looking at is a engineering drawing. It shows different profiles, like for instance right over here on the left side in the top left, you're going to see different dimensions. So it gives you an exact representation of what this part looks like from the side, including all of these dimensions. This is be the top view at the top right, and over on the bottom left you're going to see some smaller detail as far as different components of the drawing. Okay, so that's a quick example of a CAD drawing, specifically an engineering drawing with all the dimensions. There are two basic types of CAD that you need to be aware of, 2D and 3D. 2D stands for two-dimensional, 3D for three-dimensional. Just like in your algebra class, you're two-dimensional when you're graphing X and Y axis, or X and Y coordinates. That's exactly what's going on with two dimensions. In 3D we add a third dimension, which is the Z-axis, and that's usually the height, up and down. So you have left and right with the X-axis, you have up and down with the, or I'm sorry, forward and backwards with the Y-axis, and then up and down vertical movement for the Z-axis. And in our lab, the CNC mill, which is the larger of the two machines, that is your 3D we're talking about there. So the CAD software that's available out there, there's lots of it available. You can either go 2D or 3D, remembering that 3D software, all 3D software can also do 2D drawings. Some free software is available, but you can spend up to thousands of dollars, and of course companies do just that. They spend thousands of dollars on software. The more expensive software allows people to do or to more easily work on the same project. So this is really important when you're talking about professional manufacturing. If you're working for an engineering firm and you know, you have offices in different locations, and even if you don't, even if it's, you know, just the cubicle down the hallway, you need to be able to have multiple people look at drawings and make changes, and that's what more advanced software does. In our purposes here in this lab, our CAD software that we use for our CNC manufacturing is called WinCam. This screenshot actually shows you two different views. This is the top view looking down on the CNC mill, and then this is the side view looking at the CNC mill. I don't have a part drawn on this, but this would be the blank stock that has yet to be milled or drawn on in this case. So there's important things you have to understand about the CAD phase. There's two critical things that are done at this phase. The first one is you need to define the size of the part to be made. In your first exercise, the size of the part will be defined for you, but as we move along, your instructor will give you the size of the part, or you will have to measure the size of the part to be made, because that's what's going to happen is you first actually pick your stock that you're going to use, your material, and of course cut it down to size as you would like. Step 2 is to create what we call your geometries, and geometries are circles, arcs, roundovers, and all of the things that you can do given the tooling you will use to make the part. Now that's a word that you probably haven't heard before, tooling. Tooling is a very important word. Tooling refers to any of the drill bits, end mills, any tool that any cutting tool that will be used with the machine to actually cut your part. That's called tooling. And you need to note there at the bottom that you can only create geometries that your tooling will be able to physically accomplish. And I have an example of what I mean by that. This is a lettering example. Actually, there's two examples here. One of them I just found online, where it says CNC carved signs. That's a digital representation of something that was carved out on a CNC mill. Actually, probably a CNC router, which is used for wood. But this one right here, this one was carved out of a plexiglass type material, and as you can see, this is very fancy. They use a nice, script font, this Adam Bailey, and what he did was he made sure that his drill bit was not larger than the tool path. A tool path is the path that your cutting tool takes as it carves out the different letters in your words here. So, for instance, if you made a really small letter and you had a big bit in your or a big end mill in your machine, the machine would not be able to carve it out. So you need to make sure that your geometry, as we said here in the last slide, can be or your tooling can actually create your geometry that you're looking for. So that's where we're at with that. At this point, you want to move ahead and complete the CAD exercise as assigned to you by your instructor, and that information will be given to you.